Apple's new iPhone 17 Pro Max has finally been released, but loyal users are asking the same question: does it truly bring anything new?
Apple's integrated
Once
5G
again,
modem
Apple
details
presents
are
the same 8 times
undisclosed,
optical
achieves
quality
strong
zoom, the same
performance,
8
but
gigabytes of
doesn't
RAM,
officially
and the
match
same
that specification ceiling.
$1,199
And are
starting
you curious
price,
about the
even
free
as
deal in
Android
17
flagships
Pro
push far
Max?
beyond those limits. It's a story we've seen countless times: beautifully polished ads, refined materials, and minimal updates that keep Apple's profits high but do little to advance the technology itself. However, this year feels different. Tesla has officially stepped into the smartphone arena with the leaked Tesla iPhone, a device that promises hardware powerful enough to overshadow Apple's offerings. With superior specifications, groundbreaking camera design, and genuine free distribution deals for early adopters, Tesla's phone may redefine what consumers consider real value in 2025. The biggest question so far is how Tesla's iPhone achieves a true 15 times optical zoom while the iPhone 17 Pro Max remains capped at 8 times. The answer lies not in megapixels or computational photography but in the fundamentals of optical engineering. Apple's periscope telephoto system uses a folded lens pathway to reach 8 times zoom, a design first introduced 2 generations ago. It's effective but has hit its architectural ceiling within Apple's thin design constraints. Tesla's iPhone, in contrast, uses a revolutionary quad-prism periscope system, which achieves 15 times optical zoom by folding light through multiple pathways, dramatically increasing focal length within the same physical depth. This system was made possible through Tesla's collaboration with advanced optics partners who already supply high-precision imaging systems for SpaceX spacecraft, where optical accuracy isn't a feature, but a necessity. This quad-prism design effectively triples the optical pathway length while maintaining a slim chassis. Each lens element is crafted from crystalline calcium fluoride, which removes chromatic aberrations and preserves color accuracy and sharpness across the entire zoom range. The result is true clarity comparable to a dedicated 400mm telephoto lens, something Apple's fixed single-prism system simply can't achieve. Tesla's innovation doesn't stop there. The iPhone introduces true mechanical variable aperture across all lenses, from f/1.2 to f/5.6, giving photographers precise control over depth of field and light intake. Unlike Apple's fixed aperture, this mechanical system physically adjusts to brighten low-light shots or reduce overexposure in bright daylight, providing genuine optical control instead of software-based blur effects. The iPhone's ultra-wide sensor uses the same system, eliminating overexposure in sunny scenes and noise in dim ones. Beneath the glass, the iPhone's stacked CMOS sensor with built-in drum drastically improves readout speed, reducing the rolling shutter effect often seen in iPhone footage. This results in smooth, cinematic video with stability that rivals professional global shutter cameras. The sensor readout speed is 6.4 times faster than Apple's, meaning fast-moving scenes, like sports or street photography, retain their shape and clarity instead of turning into jelly-like distortions. Low-light photography reveals another massive difference. Tesla's main sensor is a 1/0.98-inch format, compared to the iPhone 17 Pro Max's smaller 1/1.14-inch sensor. While the numbers seem close, the Tesla sensor captures 28% more light, resulting in cleaner, sharper images without heavy computational processing. This means real texture, depth, and color accuracy even in dim environments, while Apple's images rely on aggressive noise reduction that blurs fine details when viewed on larger screens. In essence, Tesla's larger sensor collects more authentic image data, producing professional-quality photos without the artificial look common to Apple's processed images. Tesla also redefines the front camera experience. Apple's 18MP TrueDepth front camera is solid for FaceTime, but the iPhone's 48MP front sensor with optical image stabilization and autofocus takes it to another level. Whether you're leaning back, walking, or recording handheld, the iPhone keeps your face perfectly focused and stabilized. For content creators, professionals, or remote workers, it delivers studio-quality results directly from the front lens, something no iPhone currently achieves. Now, beyond cameras, Tesla's advantage extends deep into hardware performance. While Apple restricts its iPhone 17 lineup to 8 GB of RAM on base models and 12 GB on Pro variants, Tesla starts all Pi phones at 16 GB of RAM for no extra cost. The difference becomes immediately noticeable when multitasking. On an iPhone, running 4K video editing alongside several active apps often causes background tasks to reload, breaking workflow. The Pi phone, with its 16 GB memory and faster UFS 4.0 storage delivering 4,000 MB per second write speeds, maintains every app and task seamlessly. Apple's slower 2,800 MB per second storage can't match the Pi phone's responsiveness when handling large photo or video files. Tesla also built a dedicated neural processing unit capable of 45 trillion operations per second, offloading AI workloads from the main CPU. Apple's A19 chip reaches 35 trillion operations, but since it shares processing across Siri, Photos, and background AI, performance bottlenecks can appear. Tesla's architecture eliminates these slowdowns entirely. Thermal performance is equally impressive. With graphene and vapor chamber cooling, the Pi phone maintains consistent speeds even under prolonged heavy use like extended 4K recording, something iPhones still struggle with. Battery and charging technology show another decisive leap. The iPhone 17 Pro Max uses a 5,100 mAh battery, while Tesla's Pi phone packs a massive 6,800 mAh cell in nearly the same size. With 100W direct current charging, it can reach full capacity in under 30 minutes, compared to Apple's 40W maximum that only reaches 50% in 20 minutes. Tesla also implements Qualcomm's Snapdragon X75 modem for 5G connectivity, supporting Release 18 standards with peak speeds up to 7.5 gigabits per second, surpassing Apple's undisclosed in-house modem capabilities. In the end, the comparison between Tesla's Pi phone and Apple's iPhone 17 Pro Max highlights more than just a difference in specifications. It represents a shift in philosophy. While Apple continues to polish its image and refine minor features, Tesla is rewriting the rules of what a smartphone can be: faster, more powerful, sustainable, and affordable. The Pi phone challenges the entire industry to evolve, to build for longevity and integration rather than incremental profits. Whether it's through its 15 times optical zoom, 16 GB memory, blazing fast charging, modular upgrades, or free ecosystem distribution, Tesla isn't just introducing another device, it's defining the next era of technology.